Hey math fans, we're on section 2.1.1. Let's get started. What is a quadratic equation or function? Well, the name quadratic comes from quad, meaning square, and since the variable like x gets squared, basically a quadratic is anything that has a second degree. In other words, if you see an x squared and that's the highest exponent, then it's going to be a quadratic. When we start graphing a quadratic, you may already know that it will create what is called a parabola. It's kind of a curved shape, almost like a U or a V combined. Standard form of a quadratic always has the x squared coming first, followed by the second term, which is the bx term, and then followed by the constant, and then it's set equal to 0. Here are some examples of standard form equations. Sometimes the bx term is missing, and sometimes the very last term is missing, the constant. Another type of quadratic equation is something called factored form. Here are some examples of where the quadratic has actually been factored, because if you were to multiply, let's say, for example, the top one, x plus 2 times x minus 3, that first term is going to be x times x, which is x squared. In this section, we're going to go over the key features of a quadratic function, and we're going to take a look at standard form, vertex form, and factored form. Standard form, again, has ax squared plus bx plus c. Vertex form, h and k will actually be the vertex. Now, factored form, that will actually get the x-intercepts. Now, be careful. Anything that's inside the parentheses, you have to be careful because notice there are negatives inside each of these forms. Here's what the x-intercepts would look like on a parabola. Notice, since it curves, you're actually going to have up to 2 x-intercepts. Again, be aware of the negatives that are in the form. Sometimes you'll get a table, and following the zeros will tell you whether or not you have an x-intercept or a y-intercept. So in this particular table, we have 0, negative 4 is the y-intercept, and then we have 2 x-intercepts, negative 2, 0, and 2, 0. And here's the graph of that again. Sometimes the y-intercept is actually on what is called the vertex, which is the very bottom of the parabola or the very top of the parabola, but not always. Here I have a couple different quadratic functions drawn. One has the vertex that looks like it's actually on the y-intercept, but that's not always necessarily true. Sometimes you could get a vertex which is not on the y-intercept. In fact, this one looks like it's on the x-intercept. Sometimes a question will ask you, where is the function increasing? Where is it decreasing? So in this particular function, it looks like it is increasing from negative infinity, and I'm talking about the x values. When x is negative infinity all the way to negative 2, this function is increasing. But between negative 2 and 2, it is decreasing. But as x is greater than 2, it starts to increase again. Here's another function, which is quadratic. And you're going to notice that in a quadratic, since it's got the same shape every single time, it's going to have a section that's increasing and then a section that's decreasing. Next thing we're going to look at is concavity, and we kind of already talked about it. Concave up means it's opening in an upward direction, and then concave down is a downward direction. Watch out for the fancy words like extremum or maxima or minima. It just means the max or minimum value, and which always in a quadratic refers to the vertex. The last thing I want to talk about is even, odd, or neither functions. Is to ask yourself, are all the terms getting a sign change? In other words, if you were to plug negative 1 in for x, And if every single sign changes, an odd function. If none of the signs change, you have an even function. Now, if there's any other combination, like some of them changed and some of them didn't, then it's neither. Let's take a look at this one. If I plug -1 in here, I'm going to get -1 times -1 times -1, which is -1. So this sign will actually change. So far, it might be on its way to being an odd function. Now, if I plug -1 in here, -1 squared is going to be +1, which will not change this sign. This sign will stay the same. So since one of the signs has changed and the other one hasn't, then that means that this is a neither scenario. Let's try another one. How about the opposite of x squared plus 10? Well, if I plug in -1 right here, -1 squared is positive. And so that means +1 will be right here, and then that negative is going to stay. So no, that sign has not changed. And I'm not plugging any numbers in here, so this sign has not changed. So far I have two terms that have not changed. So if none of the signs change, I'm dealing with an even function. Now let's do one more. If I plug -1 in here, I'm going to get -1 because -1 times -1 is +1 times -1 is -1. So this sign is going to actually change. And if I plug -1 in here, this sign will actually change. So I have two terms that are, both the signs are changing, which means that this is going to be an odd function. Here's what the graphs of an even and an odd function will look like. So example 1 says that a local store's monthly revenue from t-shirt sales, f of x, is modeled by this quadratic. And then it asks, well, at what prices are the revenues increasing, decreasing? What's the maximum? What prices don't have any revenue? And is it an even, odd, or neither function? When x is less than 15, this function is increasing. And when x is greater than 15, it is decreasing. And what is that maximum revenue? Well, what you do is you figure, well, since the x value here is 15, we go back to the original equation and we substitute in 15. And we get 1,118. Next question says, well, where is there no revenue? And that's when x is equal to 0 or x is equal to 30. And finally, is this an even, odd, or neither function? Well, since when you plug -1 in to the first term, you get no change, but you do get a change on the second term, it's going to be neither. Example 2 says a quadratic function has a minimum value of -5 and x-intercepts of -8 and 4. What's the value of x that minimizes the function? And then where is it increasing and decreasing? So since this graph has a minimum value of -5 and it's got intercepts of -8 and 4, one of the first things you should realize is that the vertex lies right smack dab in the middle between the two intercepts. So what is that value? Well, the easiest thing you could possibly do is just to average it. So -8 plus 4 divided by 2 is -2. So our vertex is going to be -2, -5. Where is the function increasing? Well, when x is greater than -2, it is increasing. Where is it decreasing? Well, x is less than -2. In example 3, a table shows predicted temperatures for a summer day in Woodland, California. At what times is the temperature increasing and decreasing? So we just have to kind of analyze the y values. Where does it reach the highest temperature? And it looks like at 81. Would you agree? So then it starts to decrease after that. So we can kind of make a graph here that resembles a quadratic. And that maximum value is going to be around 4 p.m. And that's going to do it for this section. We'll see you in class.